All right, so we're here to talk about handling secrets in your cloud native architecture. So what we want to accomplish here, first of all, we need to get our mouse working. There we go. We want to provide secure, robust, and automated application credential storage and distribution. That's kind of a mouthful. What that means really is I want to be able to provide credentials to my applications. I want to make sure that those credentials aren't leakable and that my apps, that I can do other things such as rotate them, etc. We'll talk a little bit more about that down the road a little bit. All right, so quick overview or recap on what all of our roles as technologists are, right? We all want to be innovating and automating. And to put a bit more of a finer point on that, I want to call out two role specifics here. And I'm calling these two roles out for good reason. Number one, we have the platform operator, which I consider myself to be. I run a multi-foundation Cloud Foundry installation for Garmin. And I see my job as removing as many developer roadblocks as I possibly can so that developers can focus on writing software and pushing to prod. So if you don't fall into one of those two categories, I think this talk is still going to be useful for you. If you do fall into one of those two categories, I want to drive this point home even further. So this is the ultimate, right? We want to be able to just push our source code out and have it run. We don't want to have to care about containers or pods or anything else if possible. That's the goal that that Cloud Foundry has had from the beginning, and we want to take that goal a little, be a little more specific about that goal and how it relates to secrets. So again, just this is where we are heading as far as the presentation today. All right, so a couple of alternatives to ways we can provide credentials to our applications, and we've done all of these at Garmin, and some of them haven't worked really well. Some of them have worked, but we haven't liked some of the results. So the first one we tried, actually we didn't try this one. The first one, the simplest thing to do is put your creds in property files. Huge violation for security, huge violation for 12-factor. So we're just gonna not go any further with that one. The next thing we tried, the simplest way to get credentials into an application that is at least somewhat secure is using user-provided services. However, they are not really, they're not great for automation, and they also can be pretty leaky. So if I have a developer that has access to production, say to restart apps or anything like that, they can find the credentials that are being used for their application. The next option is using a solution provided by a vendor. And depending on your security vendor, your mileage may vary here. Our initial results with this one were okay, but they weren't great. So what we did is we took the broker that the vendor provided as an open source broker, a service broker, and we modified it a little bit so that it had a little bit less access to secrets on the back end and did a little less. It had some stuff in it that we didn't need, so we got rid of it. That worked real well for us when we were actually deploying our applications, but it didn't cover the full life cycle of the application. And it also had some vendor lock-in issues. So what their open source broker did is it handed a credential, or not a credential, it handed a token to the application and then expected the application to go get its own secrets so that it could run. Well, as you probably are aware with various kinds of tokens, a lot of them expire. And the expiration was long enough that we didn't notice a lot of issues until some of our apps, some of our apps started to run a little longer, or occasionally if we had to restart the broker was supposed to be keeping those tokens active. But as soon as one of those tokens went inactive, the next time the app needed to either restart, or if it crashed, or if it had to scale up, suddenly that token was no longer valid and our app could no longer go back and get its secrets. So again, vendor provided solutions here. Your mileage may vary, but we didn't find it to be a long-term successful solution. So the last option here is a custom service broker. And with Cloud Foundry, you get a secret backend called CredHub. And I think it's really important to point out, CredHub wasn't designed from the beginning to compete with a Vault or a Thycotic or whatever your corporate secret backend is. It's meant to act as a supplement to it. So what we ended up doing, and what has been working really well for us, is we wrote our own custom service broker that integrates our current de facto corporate secret backend with CredHub, so that once our applications are running, we don't have any dependency on our corporate secret backend. A few more of our goals here. We wanted to keep our apps cloud native. We wanted them to be 12-factor apps where all they knew about was the services that were provided in environment variables, and we wanted our apps to remain service agnostic. We didn't want them to depend on a corporate secret backend, so that if at some point we decided to change corporate secret backends, and we have, all we needed to do was change this broker, and all of our applications would continue running with the secrets they needed coming from the current corporate secret backend. I apologize if the comic is unreadable here. I've got a link to it at the end of the presentation, and so don't worry too much about that. But the point of this slide here is we want to follow our corporate standards. We don't want to inject a new corporate standard and get into that situation now where we have another one we have to follow. So we want to provide secrets to our applications while still following what the standards that our current environment enforces upon us. Lastly, we want to constrain complexity. We want to make sure that any nuances that our corporate secret backend has are constrained, and that the apps don't need to know about them. And we want to make sure that that if we happen to get or if we need to change secret backends, we don't have to worry about that. I'm going to flip back to our previous slide for a minute. I do want to say, if you are in the position where your company already has 14 different corporate standards for how you handle security, don't worry about it. The approach we're taking here can be used to cover all of them. Essentially, what you're going to do is you're going to write multiple brokers. Lastly, we want to make sure that we cover the full application lifecycle support. So the two that most people think about are the start and the run. We also need to cover the stop or the destroy, and we need to cover crash, and we need to cover scale. So obviously, crash and scale happen at different times down the application lifecycle, usually fairly far into the future from when the application was pushed. So we need to make sure that at all points along the way, we have secrets available to our application. How are we going to do this? I've alluded a little bit to this already, but we are going to integrate our corporate secret backend with CredHub, and we're going to do it using a service broker. The first time I heard this sounded really scary to me, but the truth of the matter is, with the Open Service Broker API, we're just fulfilling an API contract, and we're writing a Spring Boot app, so it makes it real simple and real easy to do. Yes, you are writing a Spring Boot app that is basically going between two very, very secure endpoints, but at the end of the day, when you get all the security out of the way, you're still just making API calls on one side and applying logic, and then making API calls on the other side. With the Open Service Broker API, we get to do this and use the same code for Pivotal Application Service, formerly Cloud Foundry, now Tanzu Application Service. We also get to use this for Kube. This particular broker uses CredHub. I'm not 100% sure if I don't think Open Source Kube has CredHub, actually. I'm not sure if Pivotal Container Services does, but there are secret backends within Kube that have been mentioned by a couple of the previous speakers that you could adapt such a broker to handle. Again, URLs will be at the end, so don't worry about screen capping this. I'll have a slide at the end that has all of these on it, so you can just take one screenshot for all of those at the end. So let's look at the first phase of our broker, and that is where the broker is speaking to your secret backend. Now, The one thing that your secret backend has to have, obviously, it has to have an API. If it doesn't have an API, there's no way for us to automate against it. So I'm going to use HashiCorp Vault as an example here. The link, again, in the end of the presentation covers the API docs, and we're using this API to talk to our secret backend. I can't stress this enough. Trust but verify. I think the security team at Garmin, as well as myself and a couple of the other people that developed our broker, went round and round discussing how we could do this in the most secure way possible. And the answer here is when a binding request comes in, which is one of the API endpoints for the Open Service Broker API, that bind request includes some information that you can then use to query your cloud provider, such as Cloud Foundry. You can query Cloud Foundry APIs, and you can get back the org in the space, or in the instance of Kube, you can get the namespace that the bind comes from. So what our goal here was to take as little information from the application as possible and inspect the surroundings, the org in the space or the namespace, to determine how we want to get secrets for this application. And this is where your logic is going to apply. So everybody is going to have something slightly different here, but this is where you want to take the application information, the org information, and the space information, and you want to take those, apply some logic to them, and constrain yourself to be only looking into your secret backend at appropriate locations. So as an example, I wanted to make sure that if somebody who maybe was on the customer team or the single sign-on team, if they wanted to do something nefarious and say try and pose as someone who's part of the buy team and get a hold of credentials so they could somehow try and steal product or ship product to themselves or something, they can't do that, right? They can put an app in their own space that has the wrong name, but it's going to not get any secrets because it won't look in the buy area for the buy secrets. It's going to stay, and when I say buy, I mean buy.garmin.com, or I guess online shop would be a better way to put it. But essentially, we're making sure that our apps can only get the secrets that are corresponding to the org and the space that they're a part of. So I apologize for kind of going round and round about this, but it's really important that you get that part right. You don't want to suddenly get the wrong secrets and inject them into the wrong application. Once we have some secrets, the next thing we need to do is inject these into CredHub. So gotcha that we had here. CredHub has two really important parts of their API. One is where you write a secret, and the second is where you set permissions for that secret. So what you want to do as you are creating the credentials for application A, you need to set credentials so that the application GUID has access to read those those secrets. And that way, no other app can go get someone else's secrets. They only get their own. And when that's finished, again, as part of the Open Service Broker API, when we're asked to bind, we have to hand back a result. The only thing you need to have in that result is a CredHub ref, and that a CredHub is essentially just a big bag of secrets, and refs are sort of like a path down into the bag where you get where your secrets are located. I guess bag is a poor way to put it. It's a hierarchy, so you have to know how to get to your place in the hierarchy. All right, so we have done all the steps necessary to provide secrets to our application. And again, I apologize for the eye chart here. I hope it's big enough to read. I want to walk through this though, and so this is the flow of how your application gets its secrets. And again, there's no connection between the application and our secret backend. I'm using Vault in this example. So let's walk through this. Step one, we do an app push. So right here in the right center of the screen, you can see the number 1. We do an app push, and during the app push, we make a bind request to the broker, telling the broker, hey, my name is application A, and I need my secrets. The next thing that happens, number 2, over on the right side here, we get a renewable token from our secret backend, and then we use that token to ask for secrets for this application. Again, I can't stress this enough. You want to be real pedantic about what secrets you're getting, and you want to be very prescriptive about it. And this is where your kind of corporate secret sauce is going to apply. This is the place where you need to use your logic to figure out, okay, for this org, for this space, and for this application, what secrets should this app get? So we do number 3 here. We get our secrets, and then we write those secrets out to CredHub. That's step 4A. And step 4B, we send a binding result back to the application. So that's the end of the binding. That is the only time that the application interacts with the service broker and actually gets any secrets from our secret backend. Now, our app doesn't actually have any secrets yet. It only has a CredHub ref, and we'll look at that in just a moment. But number 5 and 6 here, in the Pivotal Application Service or Tanzu Application Service instance, Diego is currently the orchestrator that spins up a container and starts it running. So Diego sees that there is a CredHub ref listed with this container's services, and then he goes to CredHub and he says, hey, I'm acting on behalf of application A, and he has this CredHub ref. Could I have some secrets, please? Again, if you don't have those rights set up correctly, CredHub goes, nah, and you don't get anything. If you do have those things set correctly, CredHub hands back secrets. Those secrets get injected into the app container as it is about to start, and then you have an application up and running with secrets. So this is, again, another eye chart, which I apologize for. It's the last one. When I look at my application and I look at the environment variables that are tied to this application, we can see here there aren't any actual secrets. I'm going to zoom in on the center part here where the credentials are listed, and you can see we have 2 things in here. Only one is required. The CredHub ref is the only thing that has to be in these credentials. These were placed here because of the binding result that came from our service broker, and they tell Diego how to go to CredHub and get secrets. The vault path, which we have also added here, is merely for convenience. So the goal here is during debug, or if I think there's some issue, I want to know where those secrets came from. It doesn't mean I get to see them or read them, but at least I can provide some debug information to a platform operator or a vault administrator. Here's what the secrets are that I'm looking for, and then from there we can hopefully debug if there's an issue. But this is all that a developer gets to see. So if as you can see here, as the developer, I'm running a CLI command to get environment variables, and all I get to see is a CredHub ref. So there's almost no way to leak these credentials. If you have SSH access to your containers, which in non-prod we do offer, if you work really hard, you may be able to find credentials if you SSH the container. It's not available in production, or it's not recommended in production as well. So in that case, you probably shouldn't see them. So we did face quite a few challenges as we wrote that CredHub broker. It's really difficult to debug CredHub. We can talk more about that later or offline. I'm coming up on time, so I'm going to step past that one for now. Vendor lock-in is also a challenge that you have to work really hard to avoid. Our corporate secret backend that we're using right now recommended us not write our own CredHub broker. And again, a lot of secret backends see CredHub as a competition instead of seeing it as something that is going to work in concert with them. So you may need to educate your corporate secret backend people, and you may also need to educate your own security team as to why you're doing this and why it's a good idea. We found the best interests of our corporate secret backend weren't necessarily in line with our best interests. We felt that using the broker that they offered us was going to give us a lot of vendor lock-in. So that was another reason that we moved away from theirs, in addition to the fact that it didn't work for all aspects of the application lifecycle. But those are some of the challenges we faced. So I've got about a minute here left, I think. The bigger picture is kind of the next step we want to take this, or actually we are taking this. And if you have written or are going to write a CredHub broker, this is really where things get exciting. You want to wrap a credential ecosystem around your broker. So getting secrets into an application is fantastic, and it's a great first step. But you want to go past that, and we want to talk about things like tracking credentials, who's using the credentials. We want to be able to rotate those in an automated fashion, and we also want to have a way to manage those credentials. So those are a few things that you want to do as your next steps after you've got a broker like this written. And I wish you luck. I hope you're successful writing your CredHub broker. If you have any questions, hit me up in the chat. And I've also got, as promised, a slide you can take a screen capture of that's got all of the references and some contact info for me as well. Thank you.